So let's go and look at question 3 of the practice test. So this is a very common question they like to ask. It says initially uncharged capacitor is connected to a DC voltage. So initially uncharged capacitor. Constant source DC voltage. What is the percentage of the source voltage that the capacitor will have after 1.5 time constants? Okay, so we can see that time here is going to be, time is going to be equal to 1.5 tau. So looking at this, if they give you a tau, it's kind of pointing you in the direction of a charging and discharging equation. And we notice that 1.5 tau is less than that 5 tau. So therefore, we're not in that steady state. So we can't just assume that everything's like operating perfectly. So if we go and write out our equation for charging and discharging for the capacitor, V of C at infinity plus V of C initial minus V of C at infinity e to the minus t over tau. And this is on your formula sheet, but it instead of V's, it has X's. It's at the very bottom. So let's go and plug in what we know. So we know our tau, we know our time constant. We don't know our tau. We know initial voltage, but we don't know that. We don't know that. We don't know this. And we also don't know our tau. But let's plug in what we know and see what we get. So we know that initially is uncharged. So that goes to 0. And we know that time is equal to 1.5 tau. So if we go plug those in, so V of C t, V of C infinity, plus, it's actually going to be minus because we'll just pull that negative out. So minus V of C at infinity, e to the minus 1.5 tau over tau, where these two taus will cancel out. So what that is that we don't have to know what tau is. We can just see that it'll cancel out in the exponential. So writing this out just a little bit more, we can factor out V of C at infinity, and we'll have e to the minus 1.5. And this will be V of C at time. And I guess I can go ahead and drop 1.5 tau into there. Okay. So looking at our equation here, if we were to let this run to infinity, so like V of C at infinity will just be equal to V of C at infinity. All right? But here, you can imagine this little bit as a percentage. So let's look at what that has to offer. Because like these two here, that value is just the percentage of VC at infinity. Because they're multiplications, because their left-hand side and right-hand side have to equal each other, we can write it out that way. So if I was to write it out just a little bit more, I could do a percentage, which I'll just denote with the capital P here, times V of C at infinity is equal to V of C at infinity 1 minus e to the negative 1.5. So these two will drop out. Then our percentage becomes 1 minus e to the minus 1.5. And if we go and plug that into our calculator, we will get 0.7768, which when you translate to percentage will be 77.68%, which is what they got after they rounded.